let's continue with the regular expression. So regular expression are a special kind of text string pattern following certain rules when in use by filters such as the grep. Its two cousins like egrep or fgrep, and the AWK, FED, and VI. For example, they are used within the VI editor for searching and replacement of strings. So a character string, often referred to as a string, is any sequence of characters. So basically, it's like a list of characters, including blank and new lines, punctuations, and control characters. They are also partly the foundation of pattern matching in programming language and are the fundamental importance in efficient Unix usage. So in general, regular expression is a text pattern that represents a set of character strings. Like assume for a fictitious regular expression language pattern that we invent a pattern rule in that this pound key represents any single digits from 0 to 9. So therefore, the pattern double pound keys would match the string 5 and 6. So remember, this is not the number 56. It's a string which contains two characters 5 and 6. So that is, the pattern would also represent all strings consisting of exactly two digits, like double zeros or 0, 1, etc. So thus, the regular expression matches to a string S if S is in the set that the regular expression defines. The rules that defines the form of regular expression vary from one operating system to another, or even from one application to another. There is no single set of rules that define how they are formed. So versions of Unix that conform to the POSIX 1003.2 standard will have the same regular expressions. Regular expressions. In spite of this standard, there can be small form differences. On the Linux Labs network, the regx man page in section 7 defines the POSIX component regular expression. So henceforth, regular expression described here are a subset of rules that are common to all Unix systems. So basic regular expressions are built up from operands and operators, much in the same way arithmetic expressions are constructed. The fundamental building block of a regular expression is a single character. So most single characters match themselves. Not all do. For example, A matches the string A, and B matches the string B, etc. And a concatenation in the context of regular expression is the juxtaposition of two strings. So basically, the concatenation is like you combine two strings together, and this regx operation of placing string patterns directly next to each other is not referring to the Unix command called cat. So the concatenation of two regular expressions R and S is the set of all possible string xy, where the R matches X and S matches Y. So for example, AB matches string AB, where A is X and B is Y, and 1, 1 matches string 1, 1, where the first one is X and the other one is Y. Okay. So the concatenation of regular expressions also comes a product. Like multiplication, the concatenation of regular expression is associative. For example, ABC can start off as the first string is AB and the third character is C. Okay. Recall that the first two letters AB are concatenated together first, and then reading left to the right, the overall product matches AB concatenate with C to become the string ABC. So generally, concatenation applies to two or more regular expressions. The explicit basic regex operator is the closure operator, which is the star character, the asterisk. For regular expression, it does not have the same behavior as in the file globes. A regular expression followed by star matches the concatenation of 0 or more string, each of which is matched by the regular expression. For example, like the A followed by star, it will match 0 or more A's, such as the only one A and double A's and triple A's, etc. And the regular expression A star matches 0 A's as well as 1 or more A's. To match 1 or more A's, use the regular expression A star will match to the string A and A followed by 1A or A followed by 2 A's and so on. And thus, the next example here is the product of string C followed by 0 or more C's and a string A followed by 0 or more A's. It will match all strings from the all possibility by concatenating a string from C star to one from A star. Okay? So the best way to comprehend it is by writing out all string length possibility of 2, then of length of 3, and then 4, and so on. So to apply the asterisk operator to more than one character as a set pattern, the operand must be enclosed in special multi-character brackets. So for example, the regular expression that matches all strings containing the pattern like AB, 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 etc. Which means the AB repeated any number of times, that is the following regular expression. So this regular expression also matches the empty string. To match a string containing at least one AB, use a pattern in a product. So one character regular expression operands and operators exist other than asterisk. So significantly, the period character, the single dot, matches any single character. It is not the same behavior used in file globes. So the list of characters matches a single character in the list, and the bracket notation follows most of the same rules for file globes. For example, in the first example, this square bracket encloses the A6J and will match to an A6J or and. Okay. And the caret character, when placed inside the brackets at the first character of the list, generates the complement of the list range. So for example, if we do not have this caret character, this representation will match to A6J and. However, if we add this character, this caret in the beginning of this regular expression, this total regular expression will match to anything but an A6J or and. However, the caret character will also serve for a different regular expression operation beyond this context. And the character classes with the asterisk operator create useful regular expression patterns. So for example, the first one will match at least to at least one sequence of CAJ, CCG, CJJ, or CTG, okay, or zero instance of the pattern, okay. So basically, the first C will match the result, the first C in the result. Say the those strings, they are all begins with the C character, right, and ends with the G character, and the character between C and G could be A, C, G, or T, like this one, okay? Or it will match at zero instance of the pattern. Certain sets of character classes have special names because the patterns are so common to use. For example, the first one is the predefined set is like this. However, actually it is equivalent to the small a to z and capital A to z, which will match to any letter, uppercase or lowercase. Okay? And there's no space between the first group and the second group. And the caret character, when typed as the very first character in the regular expression pattern, anchors the operand to the beginning. Okay? So for example, if you have this pattern, the first character is the caret character and followed by the D, R, W, and X, it will match a string whose first four characters are the D, R, W, and X. Okay? And the $sign character, when typed as the very last character in the regular expression, anchors the operand at the end. So for example, in here, sorry. The first example, it will match the string whose last four characters are A, B, C, D, because the dollar symbol, the $sign, is at the end of this pattern. Okay. If you want to match one of the special characters used for regular expression operands such as the asterisk, the square bracket, the period, or the hyphen, you need to put the escape operator to the backslash in front of it to avoid its regular expression behavior. So like if you want to match the period character, you need to put a backslash before the period character, okay? Because the period character and the asterisk operator, it has their special meaning. However, if you want to match the a star, for example, if you want to match this star in the string, you cannot directly put the star here. You must put a backslash before the star to avoid its regular expression behavior. Okay? So these special characters are called the meta characters. They can also be used as regular character in the patterns. There are other ways to do this. For now, this method is one of the easiest to remember. Okay? Eventually, this set of basic regular expression was extended to include more powerful operators and have become to be called the extended regular expression language. Some programs and executable binaries may recognize the extended regular expression language, such as VI and SED. In this unit, only a few of useful operators will be introduced. The first one is the OR operation, the vertical bar. Remember, this vertical bar is not the same behavior as when it is used in the shell redirection, like the pipeline. Okay, so in the context of extended regular expression, the pipe character is the OR character. Suppose if R and S are the regular expression, and R pipe S matches either strings that match R or strings that match S. So for example, the first one, ACG, pipe ACT, and this regular expression will match either the string ACG or the string ACT. So it's pretty easy. The third is positive closer, is plus. So this means a addition character, and it will share identical behavior as regular closer, the star, except it matches one more occurrence of the regular expression it is applied it to instead. So first one, the A plus, it will match the same regular expression pattern behavior as A and A star. Question mark. So question mark is for exact closer. As with the character, the star and the period, beware it does not have the same behavior as when it is used in a file globes. It shares the same behavior as star, except it matches 0 or 1 occurrence of the regular expression it is applied to instead. Like the A and question mark, it will match either an empty string or just one A. Okay. Back references. When basic regular expressions are enclosed in the backslash and parentheses and backslash, this brackets or an extension or an extended regular expression in the ordinary parentheses, the string that matches it is remembered for the future use. So the regular expression back references, like the backslash 1, will match the first remembered string. For example, here. So any string that matches A and A star is saved into the memory code named backslash 1, and the only string that this expression when matches are either like A B A or double A's B double A's and etc. And the extended regular expression, such as this one, will match any string that starts with the caret character and ends with dollar when with the same 3 arrangement of letters. And it even appears to look at DNA content. Okay, so that is the remembered string has the pattern formed like ACTG, ACGT, and ACGT. Okay, whatever that string is set to the memory cell as number 1. So the regular expression pattern proceeds with the last 3 ending letters matching the string stored in the memory cell 1. They follows after the initial sequence of 3 characters and any number of characters like the ACGT and star pattern. And another one is this extended regular expression. So it will match string that looks like a phone number. So the remembered string has from 0 to 1, 0 to 9. Okay, and whatever the string digit it is then set to the memory cell number 1, and the regular expression pattern will continue with the rest of characters in the pattern, all matching the string stored in number 1. In here is the digits from 0 to 9. And with the hyphen character placed between the third and fourth character of the pattern. So in general, the back reference expression from number 1 to number 9 remembers the matches respectively of the first, second to the ninth parenthesis regular expression. So for example, this complex expression will match lines of the exact form x and comma and y and double comment and x comment y. So where x and y can possibly be empty string or strings such as like ABC or like the uppercase or lowercase character or the numbers.